I'm sure you'll all be attentive. It's so much better. All right, let's look at this right here, children. First of all, how do you know that you're supposed to multiply those things together? No, they're both in scientific notation. What you should do, people, when you come up with something like this, is forget all the gobbledygook and change it and say, okay, let's say it had a mass of 2, and you had 8 of them. Let's say something weighed 2 pounds and you have 8 of them. How much does it weigh? What did you do? You just multiply. That's what you're going to do to get the answer to this problem. So what happens when you multiply things in scientific notation? This is a very important concept for you to have in your notes. So under scientific notation, and again, this is review because we did do this last year, I know, but it's a hard thing for people to catch on to. What is the very simple, easy steps on scientific notation? Multiplying is simply to do what? Kyle?
Multiply 6.02 times
Okay.
3.2.
Multiply the two numbers together, and that's kind of a goofy thing. But the nice thing is they're all 3's on the bottom, so you end up with the same thing. 0. You get 1806, you just keep moving it over a little bit each time. So when you get this, you get 6, 6, 14, 0, 0, 2. And again, they must have rounded. And then the decimal goes 4 places over, so the decimal's actually, wait, did I do something wrong?
Yeah.
What did I do wrong? Don't say yeah unless you know it.
No, you did nothing wrong.
Oh yeah, I did it right there. You get 20.0466. You write down the times 10 because you just need now to figure out what the exponent of 10 is there. And how do I find, because I multiply these together, then I multiply these together, how do you multiply things that, equal bases that have exponents together? In other words, what is 10 to the 23rd times 10 to the negative 22? You just add their exponents together. If I have a positive 23 and put a negative 22 with it, I am left with
1.
just a 1. Okay? Now this wouldn't be your answer if they asked for it in scientific notation either, but they didn't. They wanted this. They wanted it not to be in scientific notation. They said write it as a standard number. Well, 10 to the first power is the same as 10. So you're just multiplying 20.0466 times 10, which means you just move the decimal one place. If you had this as your answer, 200.466, that's fine. I don't know. They got rid of the 466 and just said 200, but either one. How many people actually got that? Besides the ones that came up and asked me about it. Besides the ones that asked their father about it. Good job, Mr. Stewart. Bam. You nailed it. I will tell you probably on tomorrow's quiz, listen to me. Tomorrow's quiz, I will probably give you a quiz that has at least a couple of those on it. How is that different than if you were dividing by, what's dividing, how is dividing by different? You know, let's say I had, let's just say I had 3.6 times 10 to the 8th divided by 9 times 10 to the 5th. How is that different than the multiplication? Really, the rules are the same, Mackenzie. You're just going to... Exactly. You'll still divide this into this. 3.6 divided by 9 is going to be 0.4. Take my word for it. Then you get times 10. But instead of adding these, like multiplication, you subtract the bottom from the top. It becomes 8 minus 5 for the exponent. It's going to be 10 to the third power. That's not the right answer because it's not scientific notation, Colton. Shoot, how do I get that in scientific notation? Make it a 4, and then what happens to this? Your choice is it's either going to be a 4 or a 2. Which one is it going to be? Alright, the deal is this. If you make this one bigger, this becomes one smaller. So Colton was right on this too. I just didn't know if he knew he was right. I wanted to test him on that. Okay, so it balances out when you do scientific notation like that. Whew. All right, so far so good. Problem number 7, children. vast majority of you missed a vast majority of you. I blame somebody else. Everybody know what happened to problem number 7? Can you get problem number 7? Oh, a coordinate plane. Is it better to be on a coordinate plane or a jet plane? This one here is probably the easiest problem in the book. The beauty of this math is it puts together all of your infinite mathematical knowledge. Okay, it's not just 2 times 2. You should be happy for this. You're tired of doing adding and subtracting stuff here. Vertices of 3, 1. So you should have a dot there, correct? 2, negative 2. Is that right? Dot right there. Negative 1, negative 1. Dot right there. And a negative 1. What did I do? 0, 2. Right there. And you end up with this shape right here, correct? And they asked you what the length of each side is. Okay, well you can't just guess and say, well, it looks like that. Math is not a guessing sort of thing. Anytime you're given coordinate planes, I think I'm supposed to stop my little. Anytime you're given coordinate planes in there, if you see something that doesn't work out nice and square where you can actually count the things, think Pythagorean theorem. Because if you think about, if you want this side right there, you can just make a right triangle right here. Here's a beautiful right triangle that has that side as its hypotenuse. And you can always count the measurements of that. How high is this triangle? 1 unit high. How wide is it from here to here? Was it 3? Yeah. So then your Pythagorean theorem says a squared plus b squared. Well, look to see if it's a triple. It's not. You get 1 squared plus 3 squared equals c squared. 1 plus 9 equals c squared. 10 equals c squared. So we talked about this at length last year. If 10 equals c squared, then c equals the square root of 10. And that's what each side, if you look at this, each one of these sides is going to be exactly that. It's going to be 1 by 3. Each side is the square root of 10, which comes up in which problem? Find the area of the square. What do you do? Multiply both sides together. What is the square root of 10 times the square root of 10? Square root of 100, which is 10. 2 identical square roots times themselves gives you that. Charlie, does that make sense? Mark on the quiz, if I give you that, you'll get it? Yes or no? You hope to? You wish to? Alright. Problem number 10. Anybody miss number 10? Somebody?
Yep.
Maybe this will be what we worked on today. First of all, you rewrote it on your problem. Tell me right here on your page you did it. You rewrote this exactly as it is. Here is what you need to think about because this is really fundamental. Some of this other stuff we do isn't going to come up a lot. This is going to come up a lot. What should be the first thing you do, Ava Wyrick?
You should do the x-code.
Negative. Negative. First thing I would like you to do is circle the different terms in this thing, because that's what you got to simplify first. And you always look for addition and subtraction signs that are not in a grouping symbol. So this is a 3-part problem. Here is your first part, if you can see that. Here is your second part, and there is your third part. You need to simplify those down to one single number, and then you're going to combine them in the end, because that's adding and subtracting at the end. So the question is this. A negative 3 to the first power is itself. Anything to the first power is itself. This one here, a negative 3 squared.
Negative 9.
Notice this is a negative 3 squared. The negative's not in a parenthesis, so you don't square the negative. You only square what's in front of the exponent, which means the 3 is the only thing you get squared. The negative hangs around because it's there, but the 3 gets squared, and you should have got a negative 9. There's a big difference between this and this. This is a negative 9, this is a positive 9, because the parenthesis, or the negative's in the parenthesis, it gets squared. That really looks like this, and you get a positive 9. If it's this, it's a negative 9. How many people got that part of it wrong? It's okay to get it wrong as long as you don't get it wrong tomorrow on the quiz, Sam. You look confused. You're trying to visualize, internalize what? Do you understand the difference between this and this? Yes or no? You can say no. Negative 3 squared and a negative 3 squared. The square only goes for what's in front of it. What's in front of this one? The parentheses. So whatever's in the parentheses gets squared. So negative 3 times a negative 3, that's a positive 9. In this, what's right in front of the parentheses is the 3. So it's just a 3 times 3 squared, and then there's a negative out in front of it, so the negative stays. This one here, okay, now notice, you can't say, that might end up being positive in the end, you can't say there's 2 negatives there, so this becomes a positive right away. You cannot deal with this negative until you take the cube of this. You have to say this is a negative 3 times a negative 3 times a negative 3 with a negative in front of it. Now in this case it doesn't matter because you get the same thing because there's 4 negatives and it ends up being positive. 3 times 3 times 3 is 27. So you do end up with that. And you end up with a negative 10 plus 27 is 17. What did I get wrong? 3 times 3 times 3, 27?
The answer is 15.
Yeah, it's not 9.
It's negative 12.
It's just 12.
It'd be negative
It's just
12.
Oh, sorry, negative 12.
See, I got 15. Share in the back.
It's not bad. I did that just to see if you're paying attention.
Yeah, we know.
It sounds like a girl's voice, that's why I questioned.
Oh.
I didn't say I didn't make mistakes. First one was getting up this far. What's next? This is getting a little long for my liking, just so you know. Oh, 12! 12 children. 12!
I got that
Raise your hand if you got this correct.
Oh,
Oh, smart.
yeah, really.
Let's see this. Gabe, when you did this, how did you do it? Did I answer the question? Did you do it all the way down to the very bottom?
No, I did square root times the square root of 10,000 times 10,100. So
Okay. Listen carefully here. There's 2 ways to approach this. Okay, you can prime factorize this all the way down into 2 times 5 times 2 times 5 times 2 times 5 times 2 times 5 times 2. Or you can there's some shortcuts to be taken here. Because you know this, that 10 times 10 is 100, and 100 times 100 is 10,000. When you see, if you can get something to the square root of 10,000, you know that it's 100 right off the bat. So when you look at this, okay, first of all, take out that 2 like Gabe did. You take out the 2, you're left with 10,000 there. You don't really have to factor that down, because if you know that the square root of a 1 with an even number of zeros in it is going to be a perfect square. It has to be even because when you multiply 2 numbers that have zeros at the bottom, you always get an even number of zeros at the end. So this one here, right away, you should know that there is a perfect square root of 10,000. Or if it helps you, you could say, okay, this is the square root of 100 times the square root of 100, because 100 times 100 is 10,000. Identical ones cross off to give you just 100. This one doesn't have any partners, so it goes like that. If you don't get that, you can still break it all the way down to the end, but it's going to take you a little bit longer to break down 100, which is 10 times 10, and 10 is 2 times 5, 2 times 5, and 3 times 5. Somehow we're losing the crowd here. Only 2 more, kids. Only 2 more. Guess which ones?
21,
Please.
13.
16.
13 is one of them. 2x to the negative 2, y to the negative 3, x, y. Raise your hand if you got that wrong. Emma Kunacek. What do I do? What do I need to do? How do I solve this? How do I simplify this? Well, first of all, this is only one term. You multiply the same letters together first, which means I need to multiply x to the negative 2 times x, which gives me there's a 1 here. Negative 2 plus 1, because when you multiply like bases together, you add their exponents. You get x to the negative first power. Y to the negative 3 times y, which is again a 1, is y to the negative 2 power. This is not acceptable because in math we do not allow you to leave negative exponents there. The fix is very simple though. You just take a letter, if it's got a negative exponent, you just move it from the bottom to the top or top to bottom, depending where it's at, and it becomes positive. So this ends up, you keep the 2 stays on top, the x goes to the bottom, becomes a positive 1, the y goes to the bottom, becomes a positive 2. This is in its true simplified form. Again, the issue is not in getting it wrong this time, the issue is in getting it right the next. And maybe, Sam, it would help if you were writing yourself notes. Like, anytime you see a negative exponent, you should think that's bad. But that's just me. Who am I, really, to tell you what I think? That's true. And the last one, like Josh alluded to, is number 16. I love number 16. These are some of the most favorite. Oh,
Thank you.
you'll remember this one next year. Children. What you are asked to do, kids, is you're asked to find what value for x and what value for y makes both of them true at the same time. For example here, if you look at this, y equals x minus 5, there's a bazillion answers for that, because whatever you put in for x, like say I put 6 in for x, if x is 6, then y is going to equal 1. But if x is only 5, y is going to equal 0. It changes because whatever you subtract 5 from whatever x is. Well, the same thing for x plus y equals 3. If I put a 1 in for x, y is going to equal 2. And it's got a bazillion different answers. But there's only one set of numbers that's going to work for both of them. And that's what you're looking for. Okay? And where that set of numbers is if you graph both of those lines, it's where the 2 graphs of those lines cross. They will cross at one single point. Now here's the part that you probably forgot. There are 2 different ways to graph linear equations, because these are in 2 different forms. This first one, what form is that? Does anyone remember? When it's solved for y equals mx plus b. I believe we did this in the lab. It's the it's the slope-intercept form. You know it crosses the y-axis at the letter b. So here, I'm sorry, I'm on 1. So here at negative 5, 1, 2, 3, 4, 5, that line crosses the axis. It has a slope of 1. 1, which means it goes up 1, over 1, up 1, over 1, up 1, over 1. So its graph looks like this. That is the first line. The next one isn't in that form. The next one is in this form, x plus y equals 3. Do you remember what form that is?
Standard.
Standard form. Who said that?
Yeah.
Together?
Yeah.
And the easiest way to solve this is just finding both intercepts. In other words, this. You can find where it crosses the y-axis by putting 0 in for x. If you put 0 in for x, what do you get for y? 3. Y equals 3. So here where y equals 3, you know that line crosses the y-axis. You can find where it crosses the x-axis by putting 0 in for y. Where does it cross the 3? So here at x equals 1, 2, 3, and then bam, you got your 2 points, you graph the line, and the place where those two will cross, hopefully is the answer, which isn't, because I must have graphed something.
Yeah, it's, you have a negative y, you get a positive y.
Oh, where was the negative y?
You put a negative y, you put a negative 3, you get a positive 3.
Yeah.
For y. For y.
Oh, this was x minus y? Wait, what?
You did it.
You put a negative 3 for y, you get a positive 3.
For a y, you would take it.
Oh! Yeah, sorry. Again, just checking on you guys. So then here's your line, and it crosses right there, which I believe is 4 comma negative 1. Sorry about that. Which means if I put 4 in for x and negative 1 in for y, both of these will be true. So I put a 4 in for x, 4 minus 1, does it equal 3? Yes. If I put 4 in for x and say 4 minus 5, does that equal a negative 1? Yes. That is the answer. This is almost borderline ridiculous. Who feels that they're better off now